Okay, so we're at a different pump here at the CHP plant. We're just going to go through a short video here to discuss recognising bad data when it's being collected, so that we can then repeat the data to ensure we don't go back to our vibration software and save bad data. So a couple of things to think about. Obviously the cable itself, we don't want it going around like a skipping rope. You know, we want the cable to be fairly stable. Obviously there's small movements, but the most common cause of ski slope is where someone allows the sensor to shock onto the measurement point position. That will excite the crystal, causing the output from that crystal to be unstable, and the FFT that results will look really poor. There will be a low frequency noise that cuts aggressively into the spectrum at large amplitude, and that's no reflection in any way upon the vibration itself coming from the machine. It's badly collected data. So let's just go through the exercise and see what that physically looks like in a real context. So I'm going to place the sensor, instead of rolling it gently on, allowing 2 or 3 seconds to stabilize, I'm going to put it on quite aggressively, and be careful of my fingers with the gloves on, obviously, to protect them, but put it on quite aggressively, and we'll see on the screen a large low frequency slope that cuts into the spectrum. So here we go. So that's been thrown on quite aggressively really, and I can see clearly on the spectrum that's on the screen a low frequency slope that cuts into the spectrum. That's no reflection of any vibration from the machine. That's badly collected data because of poor settling time, producing a ski slope. We could repeat that exercise. This time we'll go back to a live mode. So I'm just going back in the order of points to go back to the same point at the drive end of the pump. And we're going to go into an analyze mode. And I've got an acquisition here of 1000 Hertz with 1600 lines. So we're going to look here maybe in a real context at a live display, and to see how we can see initially the ski slope present, and then how it decays slowly as the sensor and the crystal stabilizes into what becomes later a good reading. So here we go now. So the instrument's reading live now. I'm going to fairly aggressively push that sensor onto the measurement location, and I can see the ski slope that cuts aggressively into the spectrum, but as time progresses that's slowly decaying, and all I'm left with now is just a nice clean FFT. The start of the spectrum is clear of any low frequency noise. I can see a running speed peak, I can see a harmonic of that, which is probably the blade pass of the pump and so forth. I've got good data that I could now store and rely upon as good stored quality data. So that ski slope, you know, it is a very important part of the story to understand, because without good data we're going to fail. Our program will not be good. We're going to get bad calls, bad diagnostics, because we're collecting bad data. So thank you.